Okay, so in this video, we're going to talk a little bit about how to do a one-way ANOVA, and I'm going to show it to you in the general linear model procedure under univariate. You can do it under compare means and then one-way ANOVA, but it doesn't give you an effect size in there. So let's just go under GLM, and the advantage to this is we're going to be using this particular dialog box a number of times through the rest of the semester. So it's good to get used to it now. Also, we're going to get measures of effect size, so that'll be helpful. You won't have to calculate those by hand. So let's find a dependent variable from our relationships data set, and I'm going to pick out current partner is funny. I'm going to make that our dependent variable, and I want to see if there are differences across groups between married people, cohabitating people, and dating but not cohabitating. So I'm going to take marital status and I'm going to make that the fixed factor. Now, the next thing you need to do is just take a look at these buttons here on the right side and go through and just make sure that you make the right selection. So we'll hit contrasts. There's really nothing here that we want to do within contrasts, so we're going to kind of ignore this. If we had more than one factor, we might be interested in some of the things going on here, but we're going to cancel that out. Let's go to plots instead, and we'll do marital status, pass that over to the horizontal axis, and then hit add. That's going to create a graph of our means, so that we'll hit continue. Okay, good. And we're going to want to do post hoc tests. So if we get a statistically significant ANOVA, we're going to want to run Tukey's. So let's click on Tukey's. We'll click continue. And then the last thing you got to make sure to do under options is make sure to pass over marital status to display means, okay? And then hit display, descriptive statistics, estimates of effect size. We can get observed power if we like, and then homogeneity tests. Those are the four usually that are pretty good to run, okay? And to get simple effects, we can just compare the main effects there. Okay, that sounds good. So let's go ahead and click OK. Okay, so up comes the output, and you're going to get a lot of output. This is just telling us how many subjects are in each group. So married, not married, dating, and our ends. And then here we get the means and standard deviations. And it doesn't hurt to just take a quick look at the means, juxtapose against the standard deviations. What we're seeing is not huge differences in these means, right? 5.59, 5.52, 5.75. The standard deviations are reasonably good sized, and we'll take a look at standard error in a second. So just looking at this right now, but I have to look at standard error as well. Just looking at this right now, I'd say probably not going to get a significant F ratio. If I had to guess, I'm thinking it might even come in, I don't know, close to 1.8, somewhere around there. Okay, the next thing we're going to do is we're going to look at Levine's test of equality of equivalence of variances, error variances, right? So what we're looking for here is a non-significant result. If we get a non-significant result, in other words, p is greater than 0.05, that tells us that there's really no evidence that the variability in each of the conditions or in one of the conditions is different than the other conditions. So we want a non-significant result. Because if with a non-significant result we satisfy the homogeneity of variance assumption for ANOVA. So here we get 0.20, that's greater than 0.05, so we don't have anything really to worry about with regard to homogeneity of variance. Now we go down to this table that says tests of between subject effects. There are lots of rows here, but really the only one you need to pay attention to is this one that says marital status. Okay, so when we look across marital status, we get degrees of freedom, our mean square, which is very small, and then an F ratio of 0.549. Okay, so really small F ratio, it's below 1. That's telling us basically there's more within group variability than there is between group variability. We're not going to get a statistically significant result because of that. And so it does calculate eta squared. It's 0.007. This is telling us there's basically no effect. Okay, like absolutely nothing. But we wouldn't even report that in our final paper because it is not a statistically significant result to begin with. right? Our observed power, our likelihood of detecting a statistically significant result, should it actually be in the population, is very low. It's 0.14. Now, the reason it's so low is because our effect size is so small, okay, that we would need a huge N for this effect size to translate into a statistically significant result. And we're just not even close to that right now, okay? All right, and so then there's going to be other printouts here. You can get the estimated marginal means for each of the factors. If we had had a statistically significant result, we would then look at our pairwise comparisons. This is where the post hoc tests are done. We're not even going to be looking at that. Well, so we get the pairwise comparisons here, and then coming down here are actually the post hoc tests. We're not even going to be looking at this. There's Tukey, because we didn't have a significant F ratio to begin with. And that's pretty much it. Homogeneous subsets are included, and then marginal means.